Okay, so your setup pack, when you get it printed, is going to look like this. That first page that you could see on the window is what's going to be printed on this. And then every page after is going to walk you through how long to cut each part, the bend order, their locations, the angles, the spring back angles, all the orientation and everything. If there's a rotation or not, we'll get to that on some of my other parts. But this first part, this rear axle frame, I've already gone through and I have cut all of my tubing out. And what I want to mention is all of these measurements for the bend locations are all done from one angle. So when it says 7 7/8 and 24 7/16, that is all from this point. And that's really important. All right. When you hook your tape measure to this, I want you to put a star on whatever end you are hooking your tape measure from. Now, when you go through and you add your 7 7/8 and then over here to 24 7/16, you need to try your best to make a line all the way around it. It can be tricky at times. It's easy to roll it on the floor and just mark it. The reason we do that is because on some of our tube pieces, like when I get to this upper main frame piece for my drag trike, that's got some rotation in it, and we'll be rotating this in this die. And if we don't have this mark all the way around it, there's no way for us to know if we're on the mark when it's put in that die. So that's why it's important to have the mark all the way around the tubing. Now, for this rear axle frame, pretty easy part to build. It's got an example of what it's supposed to look like when finished, and every page after shows you some bending instructions. It shows a breakdown screenshot of that being bent. We can find all the information from this first page. We don't really need to pay too much attention to the bend order or instructions after this page, mainly just because it's just showing a breakdown screenshot. Like I said, if we get confused, we can refer to it, but other than that, we just need the cut length and the bend order and locations and all that other information. Now, when we come out to the tube bender, like I mentioned, the star that you put on your tube, that is the part that is fed into the die first. All right? The die meaning you're standing facing it and the die is on the right-hand side, you're feeding it in from the left-hand side, your tube. That is the way that the software has calculated where to put our bends, because part of this material is consumed in this die. Part of that bend takes away from its length. If we were to put this in flipped, then when we bend this, it would be like this. It would have one side longer and the other side shorter because it was calculated the other way. So that's why it's important to put the star in first versus the opposite side. Now, if you have reversed your bend order, it's still the same thing. You'll just put your star on whatever side you're hooking from. That doesn't change where the star goes because that's the way we're feeding it into the machine. So we're going to line this up on our 0. If you haven't used this machine before, I've got tutorial videos on it on our YouTube page. And if you're one of my students, you'll have to take the safety test before you can actually use it. So I've got this set up on our 0, and the angle I want is 90 degrees, but I've got to bend it to 96 degrees. So I will set this thing up on our auto stop to 96, and we'll turn this on and bend it. Reverse it. Now the way you would check what the spring back angle is for any in particular wall thickness for tubing is what you're gonna do is you'll cut a small piece of whatever tubing you're trying to figure out to length, kind of a lot like this, and you're gonna bend it 90 degrees and then pull it out and measure how far out it's sprung away. And then you can start bending it past, and when you finally get it to meet 90 degrees when it's out of the bender, that's your spring angle. And that's what you can put in on the software. So we just bent this like that, and we're going to continue feeding this way. We're not going to pull it out and change the direction of which this is fed. We're going to continue on down the line. Now, because I know that there's no rotation of this, and this part needs to stay as level as possible for each one of these, I don't want to be crooked here. I'm going to take my level, and I'm going to make sure that this is level before I start that bend, because I want this piece to be nice and straight and flat. Both of those bends are the same angle, so I don't have to set or change any of the angles. And reverse it. And there is my rear axle frame. All right, set up just like the computer, and it bent it exactly how I needed it done. Now I would move on to my next part. When you get your blueprint and you're ready to start cutting your pieces, like you might have noticed on mine, I went and I actually labeled the parts. This will help a lot when you're starting to tack and fit your pieces together. Even all the way down to your straight pieces, I've labeled each one of these parts so I know which one is which when I'm starting to put the frame together. Those little things will help make it that much easier when you're building it. All right, now we're on to a part that has some rotation in it. We've got to rotate it 118 degrees and then 178. Now, I'll show you how to set up your angle finder on this tube, but our angle finder, if you're using the one that Bailey sells through their website, it only works in 90-degree increments. So this 118 degrees would actually be, you'd go 90 degrees and then another 28 degrees past that. And then from that point, you're gonna go back 178 degrees. So, and that's from the second bend's location. So there's a little bit of math involved as far as where you're rotating this thing in its orientation. So the way I set this up is I put this out on the end as far as I can get it. Since this is our first bend, I'm just gonna get this tight. I'm not really gonna worry too much about making sure this is level when I'm still setting this up, because it'll just rotate in the die. Now I'm going to make sure that this is clamped on this tube, and we rotate that tube just to get it level, and we will turn it on and zero it. All right, that way that's our zero, that's our home, that's where all of our rotations are coming from. Now when we see this 118, that's a positive, so we're gonna rotate clockwise like we're gaining something. And when we get to this negative 178, we're gonna go back or reverse time, and that's how we'll do it. But this first bend that we've got it set up as, I've got to set my angle at 26 degrees and then bend it. Make sure you hold on to that tube when you're finished bending it. Bring this into our next bend. And from here, we go 118. So we're gonna go to 90 degrees. And that's why it's important to have our mark all the way around the tube, so you can actually see where you're supposed to put this in there. So we just hit 90 right there. And now to hit 118 from 90, we're gonna go to 28 degrees, or I guess 28 degrees from 98, because it goes from 90 down to 0 this way. So 28 degrees minus 90 is going to be 62. We're going to set this guy up at 62 degrees. We're going to make sure we're still on our mark. Now, this angle is going to be 69 degrees. Set this up. Okay, I'm going to do my best to hold this at 62 degrees before I hit forward on the foot pedal control. Get it at least within, I'd say, 0.05 degrees. You can get real precise, but you'll just be chasing it all day. All right. So, gonna hit forward, reverse it, and again, make sure I'm not gonna let it drop and swing. All right, so this is where things can get tricky. This is a little tricky. I might have to get creative here. Maybe rotate it out here so I can actually get it to rotate without hitting our bender. So we had it at 62 degrees beforehand. And from here, we need to go the other direction 178 degrees. So what we'll do to make this easier is we're gonna rotate back to 0 and take 118 from 178, which is gonna leave us with 60 degrees. So we're gonna rotate this back to 0 and then go to 60 degrees, which is right here. I'll put this back in. I'm just gonna have to get my Sharpie here. Now hopefully not everything you do is gonna be this tricky where you have to set this up like this. Sometimes you gotta do this. One way you could get away from having to do this kind of change here is you would go back to your software, back to the CAD drawing, and you would change the bend order. You could reverse the bend order and or start the bending from the center out, and this wouldn't end up hitting right through our bender here. I've got this fancy Milwaukee level, and I'm just gonna hold it at 60 and rotate this to where that bubble is dead center. See, this is a part of fabricating that you just have to do and figure out on the fly. That it's a hard thing to try to teach because you don't know when it's gonna end up happening to you. It's that critical thinking skill that really helps out. All right, so I've got that zeroed at 60 degrees. And now I'm going to take that angle finder off, and then I'll pull it through and bend it. Oh, this is gonna be 70 degrees. I'll hold this at level, hit forward. There we go. There is my left upper main frame, just like I drew on CAD. Yeah. All right, now since there's only 3 or 4 other pieces, I'll just skip ahead to some other stuff. The rest is going to be the same.